Hello, everyone. My name is Roberta Steinberga. I am a third-year doctoral student in e-study technologies and management at Riga Technical University, Institute of Digital Humanities. This study is part of a Latvian Council of Science project on internet use patterns. Today, I will talk about student authorship and metacognitive regulation in digital text production tasks. The starting point is simple. A final digital product tells only part of the story. Students may search, copy, combine, reformulate, or use AI-supported tools. But the key question is whether the learner still sets the goal, selects and transforms information, monitors the response, and evaluates the final product. We use student authorship as an indicator of this preserved regulation. We distinguish metacognitive knowledge, metacognitive regulation, and metaregulation. Metacognitive regulation includes planning, monitoring, correction, and evaluation. Metaregulation concerns the coordination of regulatory processes themselves. We do not claim to internal regulation directly. Instead, we combine the Metacognitive Awareness Inventory, or MAI, with screen records and product-based authorship coding. Karpov's metasystem approach gives us the central regulatory framework. Regulation is represented as a cycle: goal formation, planning or monitoring, correction, and evaluation. The circular form matters because learners can return AN earlier stages and revise their actions. Digital tools may support individual operations. The theoretical question is whether the learner still coordinates the whole cycle through their own goals, decisions, and evaluation. Our three-axis model separates behavioral, cognitive, and metacognitive dimensions. The behavioral axis includes search and navigation. The cognitive axis concerns selection and transformation of information. The metacognitive axis includes goal setting, planning, monitoring, correction, and evaluation. Authorship is an integrative indicator of whether these dimensions remain coordinated by the learner. The authorship construct combines three theoretical lines. Leontiev emphasizes intention, internal programming, linguistic realization, and control. Almazova describes the organization of text. Karpov distinguished separate operations from the systemic organization of activity. On this basis, we use an original 7-level observational rubric. Student authorship is the degree to which the learner organizes the purpose, content, structure, language, and revision of the final product. The scale moves from direct reproduction to independent organization. Importantly, high authorship can still include digital support when external resources remain subordinate to the learner's own purpose and evaluation. The study addresses three questions. First, how is authorship expressed across three digital tasks? Second, how are metacognitive regulation and observable digital behavior associated with authorship? Third, does authorship predict task scores beyond time on task and general metacognitive regulation? We analyzed 178 participants completing advice, route planning, and essay tasks. Screen activity was captured every 5 seconds, and search and AI-based tools were permitted. We used 4 sources of evidence: the MAI, screen records, authorship rubric, and task-specific performance scores. RQ1 is descriptive. RQ2 uses exploratory Spearman correlations. RQ3 uses hierarchical regression, entering time first, metacognitive regulation second, and authorship third. For the first question, mean authorship was 2.13 in the advice task, 4.05 in route planning, and 1.39 in the essay. Route planning showed the highest average authorship and the essay the lowest. This suggests that authorship depends on the task format rather than acting as a constant characteristic. For the first part of RQ2, The clearest pattern appeared in the advice task. Planning and error correction were associated with authorship and with several behavioral indicators. In the essay task, overall metacognitive regulation was associated with authorship, but not with the 4 observable behavior variables. These results are exploratory. We also examined direct correlations between authorship and digital behavior. In the advice task, authorship correlated strongly with search, query reformulation, navigation, and information processing. Positive associations also appeared in the essay task. Route planning showed weaker associations. Overall, authorship and observable behavior co-varied differently depending on the task. In the third question, there is a key performance test. In the advice task, authorship added 10.2% of explained variance after controlling for time and general metacognitive regulation. In route planning, it added 4.4%, while time on task also remained significant. In the essay task, authorship added only 0.3% and was not significant. So authorship is not a universal predictor of achievement. Its value depends on the task. The results, therefore, connect the theory at 4 different levels. MAI describes general self-reported regulation. Screen records provide partial process evidence. Authorship captures learner organization of the completed product across purpose, content, structure, semantic relations, language, and revision. Performance records how well the product meets task criteria. These measures are related, but they are not interchangeable. The correlations show that regulation, observable behavior, and authorship can converge, but the pattern changes across tasks. This is compatible with Karpov's systemic view that regulatory processes are coordinated differently depending on task demands. Our design, however, does not directly measure the full internal coordination of those processes. The regression adds one more step. It asks whether the product-level organization captured by authorship is related to outcome quality after duration and general self-reported regulation are taken into account. It was in advice and route planning, but not in the essay. This confirms that authorship and performance are connected but distinct. A learner can organize a product independently and still execute it poorly, while a polished product may rely heavily on external organization. So the practical message is not to treat digital support as evidence of lost regulation. Assessment should distinguish what learners report, what is visible in the process, who organizes the product, and how well the product meets the task criteria. Thank you.